without further ado, everyone, welcome to Midweek with Max. Appreciate you all being here. I'm Rick, joined by the Johns, a Joshua, and of course, Max Sanchez, our co founder. So, without further ado, kicking it over to Max for weekly update, and then we can get into the exciting world of hemiBTC and I believe a focus on staking.
All right, awesome. Welcome everyone to another week of Midweek with Max. First, we'll go, like Rick said, through engineering updates, and we'll talk a little bit about staked hemiBTC. We are going to do another session next week. We did delay the launch of staked hemiBTC from this week just due to the holiday week. We thought not a lot of people are going to be looking at stuff using it, so we thought it'd be better to launch that next week. But we'll still talk through some details about that and what you can expect, and then we'll get into questions. So let's see, starting off with engineering updates. We've got V2 essentially deployed to testnet. We have one more piece to do for mostly spinning down some old unused infrastructure, but all of the V2 updates are running, staying in sync, everything's looking good. We also got the rebase for Fusaka in for mainnet support. And so that hasn't been merged in yet, but we're going through and testing that both on testnet and mainnet in the next couple of days here. And then we will be releasing instructions for how to update your nodes, especially if you are running a mainnet node. You will need to follow those instructions before December 3rd when the Fusaka update happens on Ethereum mainnet. So we'll be getting instructions out for that. There is an update to with V2 that does a very large, expensive database upgrade. So we most likely will be providing data directories for people who do want to use those, at least for the new upgraded TBC database. So stay tuned for that. Beyond that, been continuing to work on ZK provability. We're pretty much done with the HBit VM white paper. JCV is just doing his final edits, so we should be getting that out shortly. We may release a draft of that in Discord for people to review, and then publish it a little bit later just to give people a little bit more time to look through it, because we do want to do an HBit VM breakout session. So in addition to Midweek with Max, doing another 30-minute or probably an hour AMA to talk about all the technical specifics of HBit VM. And so that just gives people a little bit more time to read through it, understand it, and if they want to participate in the AMA, have enough time to digest it to ask the right questions and understand that AMA. So stay tuned for that. Beyond that, Airblock stuff is still coming. Again, apologies for the delay there, but it is coming, as will the POP payouts, getting your Hemi tokens for liquid Hemi tokens for POP points. So that is still in progress. It's still a priority. Other things have shifted around, but it is still being actively worked on and will be out soon. And beyond that, I think that's pretty much everything on the engineering side. So I'll jump into staked hemiBTC. So like I mentioned last week, we are launching a staked hemiBTC product, and the goal of this is essentially to make it easier for people to access Bitcoin yield without having to understand all the DeFi chutes and ladders, and do so in a way that's fungible, a good user experience. And so next week, we will be launching the staked hemiBTC product. There's going to be a couple different parts to this. So the first is a liquid ERC20 staked hemiBTC. So you put in X number of hemiBTC, you get out X number of staked hemiBTC as a ERC20 that you can go and trade, use in other protocols, use as collateral. And under the hood, that's going to be using a Morpho market initially, or Morpho vault rather. And over time, it's going to be a dynamically managed strategy. So as there's new interesting Bitcoin yield sources, those are going to be swapped out, and the allocation of hemiBTC inside the staked hemiBTC product will be reallocated to different yield strategies under the hood. And that's totally opaque to the user. So obviously we'll be keeping people informed of what changes we're making and how the allocation and yield profile is changing. But from a user perspective, you don't have to do anything. You can just set it and forget it. So your Bitcoin's automatically chasing the best risk-adjusted yield sources under the hood. You just put it in one time and then come back whenever you want and collect the revenue and yield on top of that position. And you can, again, it's fungible, so you can trade that at any time super easily. And then the second wave of that rollout will be giving people direct access to the underlying strategies. So we're doing sort of a two-tiered approach where The first tier is this simple managed staked hemiBTC position with a liquid wrapper token or a liquid position representation token. It's a little more precise. And then for people who want to do more advanced stuff, we'll be exposing the strategies directly. That's kind of a V2, so it won't be part of the initial staked hemiBTC, but as we add more yield sources, we'll open those up to people using them directly. So people who want to do more advanced stuff can use those strategies. Some of them will have liquid representative tokens. Some of them will not, depending on the uh, nature of the yield source. So, for example, some yield sources may require a longer lockup, so it's not immediately redeemable, and those are more, esoteric. You have to understand how they work and understand the risk parameters and stuff. So those, there may not be a token. Other ones that are more liquid, those will be separate liquid tokens. So it'll be that two-tiered approach: set it and forget it at the top level in a managed position, and eventually the allocation of that strategy will be turned over to governance. So that'll be based on VE Hemi and possibly hemiBTC stake weight. And then beneath that, if people want to get more sophisticated, they can engage directly with different yield strategies that are still abstracted a bit from having to use all the DeFi chutes and ladders, but it's another level of granularity that people have access to if they want to know that they're always exposed to this exact risk profile. They want to always be in a Morpho vault, then they can engage in that strategy directly instead. So that's the staked hemiBTC product. Stay tuned for that coming out next week. So that's a preview of what's to come, and then we'll probably have another breakout next week to talk a bit more about it after it's actually launched and live and people can use it. Let's see, beyond that, the other thing that's going to be coming in the near future, and we did talk about it a bit last week, is the hemiBTC ecosystem dashboard. So it's a mix of statistics, knowing how much inflows and outflows into the system, the collateralization of Bitcoin backing hemiBTC, and transparency around that, so you can see very easily the one-to-one backing of hemiBTC versus the BitVM vault versus the Bitcoin tunnel vaults. That eventually with HBitVM that'll be updated to show the backing and construction of the HBitVM vaults. So that's a future item for eventual Bitcoin tunnel upgrade to use HBitVM. But that dashboard will be coming probably sometime next week or the week after. I don't have an exact ETA on that, but it's almost done and in review and testing and getting data sources set up. So it'll be coming in the near future as well. And with that, so we will have another hemiBTC focused breakout session after the product launches to talk more about it. And again, like I mentioned, we'll have the full tech deep dive HBitVM AMA most likely sometime next week. So we'll announce that as well. And with that, I think I'll pass it over to Rick to start going through questions.
All right. Thank you for that, and looking forward to the next one. Okay. Oh, as Josh has written here, this is the when section. So there might be some redundancies, but I'm just going to breeze through these. When is the next VHEMI reward claim?
Probably in the next 2 weeks. So probably first week of December, I would imagine.
All right. Um, when updates for VBK? I believe you covered that already.
I did, yeah. No updates there, but it is still coming soon. So again, apologies on the delay, but it is happening.
All right. This is an interesting one. Oh, there's a slew of interesting ones actually. Uh, when will the very soon meme coin launch on Hemi?
I mean, that's something the community could jump in and do if they wanted to.
Yeah, someone
or
should make that.
that would be funny. You need to get the trademark in there too.
Absolutely. Yeah. All right, Alex. Yeah, put the mods on that. Get a very soon meme coin cooking. Um, who the hell wrote this question? During Hemi's Christmas dinner, is it true that Jeff dresses up as Santa? And if so, can we have some photos?
I can neither confirm nor deny the rumor.
Okay, reasonable, reasonable. When incentive season 2 or an update about anything season 2 related?
We have covered this in the past, and I'll let John also speak to this a bit. So we're moving away from these monolithic seasons with points more towards liquid incentives because they're easier for people to understand. They're more immediate feedback. You do something and every day or week or whatever, depending on the incentives, you get liquid incentives paid out directly for your position. Or in the future, we'll have some things that emit VE hemi positions, but still you're getting that feedback on a rapid time scale instead of waiting months for season to end. So for now, we're still focusing on that approach. We do plan to do some things around more of a season structure, but it's lower priority. For now, anyone who is interested in yield, post the link here. For the moment, this is essentially the source of truth for rewards, or rather, liquidity mining incentives. So that's the Merkle campaigns. There's a bunch of stuff on there for providing liquidity to different sushi swap pairs. There's also some lending market items on there, and also I think Spectra, and then the direct access to the hemiBTC vault, which is the ClearStar reactor that uses Morpho. And that's going to be also the initial yield source for the staked hemiBTC. So if you want to go through the DeFi chutes and ladders, you can use it directly today. And if you want something that's a little more easier, one-click set and forget, then you'll be able to use staked hemiBTC, and that will be using that strategy initially under the hood. So I'll throw it over to John Greenwood if he wants to add anything to that.
Well said, Max. Not really much to add there. I think there will be more to come, and something that's like should gap out kind of your need for more gamification, but really want to lean on the fact that we're looking at primarily liquid rewards as the vehicle. So I'll keep it short, but look, keep an eye peeled, and we'll say something as soon as we have more.
All right. Our final when question. I think you all know what I'm about to ask. When OG roll?
Still in progress. I don't know if Josh wants to give an update. There's a few items on the UI side that need to be finalized for that. There's been other priorities getting V2 and Fusaka shipped, but it is still in progress and it should be coming out soon.
Josh, anything to add?
As Max said, that's mostly UI components left. It's still being worked on. We're just currently focusing on other more important things, but we have not forgotten.
All right. Before we move on to the next section, I would like to turn the reins over to JCV momentarily. JCV, you recently had a contest for the Hemi Hippo, and you are the judge and jury, not the executioner. That would be weird. So I'm going to turn over the mic to you to address the contest and announce the winner.
All right, cool. Yeah, so just as the reminder, hippos are Hemi improvement proposals, sort of along the same lines as BIPs and EAPs and all the other alphabet soup of things projects have done. They're a good way to see sort of major either network or process things that are going on Hemi. It's on GitHub, and since it's on GitHub and it's got a README, I wanted a logo because good things have logos. Now, first, I just want to, not the winner, but sort of a one that I wanted to call out as a, I guess, runner-up was, there's the one by Broken that has a hippo in front of sort of the Hemi logo with some either clouds or birds or something. Not the winner because I don't think it'll look right where I want it, but a shout out. I really, really like that one because it very much reminded me of the album cover from Faith No More's Songs to Make Love To EP. Not that I'm sure too many people here remember or care about that, but goddammit, that is a great EP by one of my favorite bands. So for reminding me of that, you do get a shout out, even if it's not the winner. Now, the winner, the one that's going to go in the repo and we're going to use, is the David Wellsberg's one, which is the Hippo Cross Hemi logo. So that is also a I like the sort of hippo on top of the logo. I think it'll look good on the, actually in the repo, and it looks like one I can probably import and 3D print a copy of, which is also was not a requirement, but was definitely something that when I saw that I thought, oh shit, that would look good 3D printed like the Hemi logo that I did. So that's the one.
All right, thank you. David, we will be opening a thread with you shortly to address your tokens. Congrats on your new role of community creative, and we will be adding your design to the Hemi Community Collection available at the Hemi Community Store. And with the holidays coming up, what better time than to check out the Hemi Community Collection? Okay, that's my ad for the day. Let's get back to questions.
I
Moving,
really like how you slipped that ad in.
that wasn't bad, right? And thank you, Alex, for posting the link. Um, just remember, we have mugs, T-shirts. So, all right, I'm going to stop shilling the community store, but it's very good. There's a lot of really cool stuff there. So moving on to the pop section. Oh,
I
sorry.
just want to say you need to find a way to get us a Hemi Chia Pet. The same.
Oh,
Yeah.
wait a minute. Are you saying what I think you're saying?
It
I
sounds like
think I
some
am.
hair merch.
I was gonna say it sounds like hair merch. It sounds like a Max Chia Pet where you can grow his haircut.
Oh god.
Josh, if Fourth Wall provides that, if not, I think we should suggest it to him because that would be absolutely incredible.
Unfortunately, they don't at this time.
Son of a bitch. That would be the gift that keeps on giving all season long. And for other gifts that keep on giving, check out the Hemi Community Collection. Okay, now seriously, back to questions. All right, Pop. When will Pop mining rewards become liquid?
Should be shortly. I did briefly touch on this, so given the holiday week, hoping to get that deployed early next week. So again, there were some delays on that with all the V2 shipping, but that should be coming very imminently.
All right, one more in the Pop category. When will you could probably finish this one yourself, Max, but what the hell? When will the new Pop mining algorithm be implemented?
Also soon, so there's a lot of moving pieces with the V2 update and Fusaka, so we keep rebasing the pop payout stuff on the latest, so we don't have to do a bunch of upgrades and track a bunch of different branches. So now that we have the Fusaka rebase in, I'm rebasing the pop changes on top of that, and then we should get that shipped out to testnet either tomorrow or right after the Thanksgiving break, and then probably mainnet 2 weeks later, assuming everything looks good on testnet.
Right. Rock and roll, buckaroos. It is coming. On to some further engineering questions. Ethereum recently announced Lean Ethereum. How and will this change impact Hemi?
See, how long do we have? No, that's a really
As
interesting
long as you want,
question.
sir.
So a couple things so Lean Ethereum's this like basically 10-year roadmap of major improvements to the Ethereum protocol, everything from better peer-to-peer networking, faster blocks, faster finality, post-quantum resistance, uh, using ZK proofs for a lot of interesting things, possibly an update to the EVM to make it more easily ZK provable. So there's a lot in there that could potentially benefit Hemi, either just because it's adopted on Ethereum or because it's stuff that we can also reuse in the Hemi network itself. So starting with fast finality, because I think that's an interesting immediate impact one. Not immediate as in it's going to be shipped soon, but as in it's easy to understand the benefits. So fast finality, I think they're targeting 3-slot finality. So it'd be initially 36 seconds. So a couple years ago, there was a proposal for single slot finality on Ethereum, which worked in the optimistic case, meaning that the network's well connected, everyone's gossiping and processing peer-to-peer messages very quickly. And basically, it would make it so that the entire Ethereum consensus set would be able to, or a large portion of it would be able to quickly sign off on finalizing blocks in the chain. And so instead of having this 2-epoch delay that's primarily there for handling network overhead and the computational overhead of BLS signature aggregation, this would basically accelerate that and let that a similar process to that happen much more quickly. So we wouldn't be waiting multiple epochs for block safety and finalization. So that's certainly interesting. That's something that at some point we could adopt into Hemi's decentralized sequencing as well. In the past, we had talked about doing our own variant of single slot finality. So whether we end up using our model of single slot finality or Ethereum's, 3-slot, probably slightly more stable, given that it has a little more time to work, but obviously not quite as quick to finality. That's TBD, but either way, getting faster finality on Ethereum itself is always a good thing. That can be used for faster Ethereum tunnel transfers, although still there you're limited by the time for POP, so probably not a huge effect on the Ethereum tunnel side, but it would definitely benefit, especially deposits and other sorts of cross-chain things between Ethereum and then other networks to Hemi. So maybe not so much directly Ethereum to Hemi, but something like going from Ethereum to another network, doing a swap in that other network, and then bringing that over to Hemi through some sort of, cross-chain swap or transfer aggregator using something like a layer 0. So definitely improvements there. And again, those are things that, depending on where we are with our own single slot or fast finality, something that we could adopt on our side as well. They're also going to be doing some work on the EVM and possibly reworking it to be more easily ZK provable. So that would reduce the costs for ZK provability and also increase the speed at which EVM state transitions, or in our case, HVM state transitions, could be ZK proven. So that kind of plays into finality a bit, because if you want to have light clients that are fully powered by ZK validation and you want them to have fast finality, then you need to have a very fast ZK proving algorithm as well. So that's one of the things the RISC-0 and I believe the SP1 team as well, but definitely RISC-0 have been working on, is trying to figure out how, even with Ethereum's current EVM execution environment, they could ZK prove Ethereum blocks as fast as they're produced. I think right now RISC-0's generally able to do it on about $100,000 GPU cluster. And so if we can get that down to where it's reasonable that every validator on the Ethereum network could have access to the hardware they need, or have some sort of decentralized, kind of like you have proposer builder separation, where you have somebody can propose for MEV marketplaces, somebody can create the block, and then a validator who is allowed to make the block at that slot can choose which of the blocks from the block builders that they want to actually build as their own block. So you could potentially have I'm not sure if Ethereum is planning this, but you could have a similar separation between block construction and block ZK proving, and if you could integrate that potentially into the proposer builder system, where you could have proposers delegate out, or they do the ZK state transition computation, and then the validators can just pick which ones they want to use. So again, faster ZK proving in an EVM that's designed around enabling faster ZK proving would make that much more of a practical reality. So you could have real-time ZK lightweight clients to the network. And also, we ourselves are going to have to do a lot of ZK proving of the Ethereum network for HBitVM. And so if the Ethereum network eventually adopts a system where participants of Ethereum themselves are producing ZK proofs, that makes our job a little bit easier as well. So we no longer have to subsidize Ethereum ZK proving, or at least parts of it. And we could just use those existing ZK proofs and then add in whatever pieces we need. So for example, if they're just doing ZK proofs of EVM state transitions, we could also add just, our more lightweight ZK proofs of, beacon consensus or whatever other missing pieces that we need to add on our side. So it could be some benefits there. One of the big things is post-quantum cryptography. So Ethereum is going to be at some point adopting a number of post-quantum cryptography schemes. So there's a couple different areas of the Ethereum protocol that right now are vulnerable to quantum computing attacks. And I don't say that in a fear-mongering way. I think personally that realistic quantum computing attacks against current cryptography is a ways away, and I think a lot of the estimations of it coming in, 2028 are a little bit exaggerated and require some ridiculous engineering milestones to be made by the people developing post-quantum or quantum computers to break post-quantum cryptography. Yeah, John, if you want to
Exaggerated
talk
is
about
a
this.
nicer word. That's a nicer word than I was going to use for it.
Yeah, I think we have some time, but on that note, it is good to be thinking about these things far before they're actually needed, so we're not, scrambling when there is some, unexpected breakthrough, or we just, do nothing for 10 years and then all of a sudden get bitten. So again, I'm not too worried about it in the shorter time span, but it is a good thing to add. And in order for Hemi to be fully post-quantum, Ethereum would need to be post-quantum, and also Bitcoin would need to be post-quantum. There are, yeah, we can have a discussion about post-quantum. I'll try to keep that short, but basically on the Ethereum side, the major parts that need to be upgraded. So the first thing is KZG. So KZG is used for DA blob inclusion. And the reason they originally did KZG was sort of an overkill back when all the beacon nodes were holding all the blobs anyway. You could have just committed them in a Merkle tree, and we're talking about a small number of blobs and a very short Merkle proof, 3-4 layers of a Merkle proof of inclusion. But the decision was made to do KZG from the get-go, so that as Ethereum scaled out their DA layer, they would be able to have some nodes store some of the DA blobs. And so now, post Fusaka on testnet and then shortly coming on mainnet, there is DA sharding, which basically means by default, if you just spin up a Prism node or whatever consensus layer client you use, Lighthouse, whatever, by default, it'll only subscribe to a subnet of the DA blob, so it'll only have a portion of the total DA blobs. And then if it needs to get a particular DA blob for some reason, it can reach out over a different peer-to-peer subnet to nodes that are holding that blob and get the actual full data for it. And you can also now run the consensus layer client in a mode where it subscribes to all of the DA blobs. So if you're running something like an L2, where you need all of the DA blobs in your L1 node that you're talking to and using for DA, and you can enable that and still get all the DA, but it means for 99% of the people who want to run an Ethereum node but don't need all of the DA data immediately available, you're able to be much more efficient. So the practical implication of that is that Ethereum can scale out DA to 10 to 100x the current DA throughput, and do that in a way that doesn't increase the bandwidth and compute requirements of every node of the network by 10 or 100x. And so right now that's using KZG. KZG is vulnerable to quantum computing attacks. So they need another aggregation scheme, which is not trivial. I don't know which version or which type of cryptography they're looking at, but there are some set inclusion post-quantum algorithms that could be potential candidates. And again, there's possibly a way to use ZK proofs in a clever manner to work around not having something that natively supports all of the aggregation and efficient set checking that KZG provides. So that's one area that needs to be upgraded. Another area, and this is probably I'd say the hardest, is replacing BLS. So right now, Ethereum uses BLS signatures for everything on the consensus layer that validators are signing. And so the reason BLS works so well is because BLS signatures can be easily aggregated, and they can be aggregated non-interactively. So for example, on Ethereum, the way that the current finality algorithm works is each epoch, you have 32 blocks, and then the validator set of, right now I think it's close to 1 million validators. It was over 1 million back in June. The 1 million validators are divided into 32 equal sets for the epoch, so one for each block. And then they vote on what they believe is the current tip, the current safe block, and the current finalized block, or safe and finalized epoch. And one of the things that Pectra improved was the way that those attestations are aggregated. So by default, you have 1 million validators. Divide that by 32, you have I'm not good at mental math, but something like, 30,000-ish validators per slot. The naive solution would be you'd have, 30,000-ish signatures to validate, and they could be over a couple different messages. So there's a little bit of additional complexity there. With signature aggregation that BLS provides, what Ethereum does, it has these aggregators as part of the peer-to-peer setup for the attestation committees, where you have a bunch of validators who are attesting to their view of the current chain, and then you have these aggregators who are seeing all those peer-to-peer broadcasts, and they're aggregating the BLS signatures together. And then you can have multiple layers of BLS signature aggregation. So you can have somebody aggregate 2,000 signatures of this, subcommittee, and then somebody else do another 2,000. And then somebody above that can aggregate the aggregations of those two sets of 2,000 together. And so that property of BLS makes the way that Ethereum supports, potentially millions of validators very efficient. And for post-quantum, there's, to my knowledge, not currently a good post-quantum signature algorithm that can do aggregation natively. There has been some work. There was a team, I think as part of QRL, who developed a post-quantum lattice-based signature scheme. I think it's based on crystals, dilithium, or very similar to it, that does a lot of aggregation, but only up to a certain threshold, which I think right now is, they claim 30,000. I haven't looked deep into it, but that's one of the limiting factors. There's also ways around that potentially with ZK proofs. So you can sort of use, well, not sort of, you can use ZK proofs to aggregate non-aggregatable signatures. So you can have a ZK proof that you verified all the signatures, and then that ZK proof itself is proof of the signatures over a large set of validators. So that could be a potential option instead of trying to support it natively in the crypto and have a signature scheme that natively allows aggregation. You could have a ZK proving system that proves the verification of non-aggregatable signatures, and then that acts as your aggregation. So I think that may be the direction they're currently taking it. I haven't deep dived on what their proposal for that is yet, but that's definitely interesting, and that's something that on the Hemi consensus side, we could adopt whatever approach they use as a way to also be post-quantum for our own decentralized sequencer system. So there's improvements there that we can benefit from. And then the final part of post-quantum is the actual signatures used for transactions on the network. And that's, of course, easier because you don't have the same efficient aggregation needs. So that's just choosing one or a handful of post-quantum algorithms and using them. The drawback, at least currently, of post-quantum is that, generally speaking, the signatures for post-quantum signature schemes are a lot larger. And so, again, that's an area where ZK proofs could be used to compress them. So you could say, instead of your Ethereum block coming over the wire, having all of the native signatures embedded in it and then verified by the client, you could have a ZK proof that all of the signatures in the block are correctly validated. And then you could have the signatures, if somebody did want the raw data of them, included as like an optional sidecar. So there's some cool stuff there that could all be adopted for making Hemi post-quantum. Beyond that, let's see. I think that's pretty much all the exciting stuff, at least that I'm aware of in Lean Bitcoin or Lean Ethereum proposal. There's also, I think there's something they're doing with an improved version of VDFs, but I haven't dived into that. So there may be some cool stuff there that you could basically piggyback on a better VDF that's provided by Ethereum and could bring that onto the network for use. But I'm not too familiar with that part of the proposal yet.
All right. Thank you. This next question doesn't quite fit under pop, which is good because we wrap the pop questions. I imagine JCV will have some very strong opinions regarding this, and it's shockingly a non-NFT question from Miracle. So that in itself is a early Christmas miracle. See what I did there? Will quantum computing destroy Bitcoin and ETH in the future?
Okay, I do have thoughts on this. So the first thing is, how quickly is quantum coming? Or is meaningful quantum computing coming? Meaning, how quickly will we have a quantum computer that can, run something like Shor's algorithm or what's the other one? Groves, I think. to factor very large enough numbers to be useful. And every week or two there'll be a headline about some team doing something bigger. And that's great. And real meaningful quantum computers are just a couple years away, just like they've been every year for the last 20 years. It doesn't mean there's not real serious progress in it. But if you look at most of those things, and if you follow like the professional cryptographers, a lot of them are getting cranky that you'll have these really big claims, and then you see, yes, someone was able to factor a really large number, but they specifically picked the really large number that they were going to factor ahead of time to be one that they could factor easily. So the claims have a little bit of, they're still very cool physics experiments, but they're not as, it's not as meaty as they want it to sound, which goes to show that, as always, when you read headlines about scientific work, you have to remember the people writing the headlines are usually literate, but not scientifically literate. So you have to be careful at how you interpret them, because Christ knows the people who wrote the headlines were not careful in how they interpreted the results. Jesus Christ, I have all sorts of examples from like astronomy where I could really get annoyed at the way people have written scientific headlines. But regardless, for quantum, yes, there is real progress. It's questionable if it's really as far as it is. Is it possible that there's, some dark government lab somewhere, pick which particular government you're afraid of, maybe all of them, I don't know, that might have a quantum computer that can do more, bits than the ones that we see from academia? It's possible. If they are, do they have better things to do than hacking Bitcoin? Maybe. I don't know. But point is, it seems unlikely that this is something we need to be, that's going to get us tomorrow. Now, with that, at some point this will happen because, progress always moves on and eventually people can do bigger and better things. What does that mean for Bitcoin specifically? Because that's what I've been following. The Bitcoin addresses, the way those are done, that there's a real threat. And there have been discussions for quite a while in the Bitcoin development community as to how we solve this. And there are all sorts of, post-quantum or quantum safe or quantum resistant methods for doing Bitcoin signing. The problem is, what happens to all of the keys that existed before? You may, because there are ones that can't readily update. So what happens to all of Satoshi's coins? It would be very, very, very bad for all the Satoshi coins to all of a sudden be accessible to a quantum hacker. So it's not clear what the best solution is, because there are solutions that people have proposed that make older coins inaccessible if you don't upgrade within some period of several years. Is that okay? Maybe, but some people think of that in the Bitcoin world, think that's a very bad thing. So maybe we need a solution that there's always some escape hack, some way that you can still access those coins. And the point is, there's a hell of a lot of options that people are looking at. Some better, some worse. The real fear I have is not that there's no options, not that quantum can break Bitcoin, but that, can the Bitcoin development community actually agree on one solution, or hell, agree on two solutions before either quantum is the threat that we worry it is, or before, I don't know, at the rate they decide sometimes it might be before we're all dead and gone. So not a threat for today, a threat we should be looking at today because it's better to deal with it now than later. There are possible solutions. Which one are they going to go with? Who knows? But that's my rant on quantum for Bitcoin anyway. Ethereum, at least the Ethereum community makes decisions quicker. So there's far less, there is far less concern there in that there'll be decisions, they'll come up with one, will it be perfect? Probably not, because there are no perfect solutions to complex problems, but they'll still have one. Bitcoin's going to be a longer road, a lot more arguing, but something will come up because there are already possibilities there.
A
And
few other things to go ahead.
no, that was, I was going to say, let's see, I was going to throw it over to you to see what detail you wanted to add in there, or what in there you wanted to hit.
One of the things I think you said at the very beginning was people, a lot of these articles coming out don't really understand or do a good job of translating, at the very least, to be generous, the actual quote unquote quantum breakthroughs. So one of the big things people aren't aware of is the difference between physical and logical qubits. So you'll see articles that, you'll see one thing that says Shor's algorithm can be broken on, 256-bit security key with 2,500 qubits or whatever. And then you see another announcement that XYZ company has a quantum computer with 3,000 qubits. Whatever the latest number released is. The reality is there's physical and logical qubits, and they're orders of magnitude apart. So there's physical qubits, which are the actual qubits on a chip, and then there's logical qubits that you can actually use to implement a quantum computing algorithm. And the gap between physical and logical is closing. But basically, you need, I think the current, don't quote me on this, but there's something like, I think the best implementation right now is there's something like 200 physical qubits for every logical qubit. And you basically, and again, I'm not a quantum computing expert by any means, but just diving in and understanding what's really going on here. You need a bunch of these physical qubits to have enough qubits to reduce the noise so that you can have one actual real qubit that you can use. It's kind of like, it's a very bad analogy, ECC memory, where you have more memory than is actually usable because some of that's being used as parity. And so with quantum computers, it's not that you have, a small fraction of your total memory used for parity. Again, we're not talking about memory, we're talking about computing here. But with quantum computing, right now, the state of the art is you need at least 2 orders of magnitude more physical qubits than you have logical qubits. So if you want to break Shor's algorithm, and that requires, or if you want to implement Shor's algorithm to break SECP 256K1 signatures, whatever, and that needs 2,500 qubits, you actually need, maybe 250,000 or 500,000 physical qubits on the chip. And as you scale up more physical qubits, the amount of noise in the quantum circuit increases, and so you also need additional physical qubits to handle that additional complexity. So not only is it, there's not a fixed ratio of physical to logical qubits, it's as you scale the number of physical qubits, you also need more physical qubits per logical qubit that system can actually make usable. So if you see Shor's algorithm can be factored with 2,500 qubits, and you see that someone has a 3,000 physical qubit machine, it doesn't mean that it's broken. So one important distinction. Then also on the Bitcoin side, I think JC already pretty much exhaustively covered this, but one of the things that people are doing is moving towards, which is just good practice in general, but single-use Bitcoin addresses. So right now, if you use any sort of recent version of Bitcoin addresses, basically everything but beta public key. If you use beta public key hash, if you use the SegWit or Schnorr/TapScript addresses, those are all protected by hashes, and so those are generally considered quantum resistant. There is Grover's algorithm, which makes breaking, I think it brings the security of a hash function down by a factor of 2 in the exponent. So basically SHA-256 now is quote unquote SHA-128 or something, which is still enormous. And you got to remember also the number of cycles that you can do on a quantum computer is much less than you can do on a traditional computer. So 128-bit security against quantum is better than 128-bit security against classical computing. But even in that case, your public key always necessarily has to be exposed when you actually spend the Bitcoin transaction. And so it basically means that you're not a sitting duck for potentially years of somebody trying to break your key. But when you do broadcast your transaction to the mempool today, even if it was hidden by a hash and you never revealed the public key before, meaning you never spent from that address before, when you do a spend, at least until it's included in a Bitcoin block, you are still vulnerable to a quantum computing attack. So it's not an ideal solution, but it's the best we have on Bitcoin at the moment. One other thing that's interesting, more from just a sort of a, what could theoretically be possible with Bitcoin as it is today. So with circuit garbling that BitVM3 introduced, so originally with BitVM2 style designs, we were very, very constrained with how much input data that the operator of the vault system could attest to in a Bitcoin transaction that then is that shared state between multiple transactions to make sure that if they claim, they have this data that satisfies the ZK proof, then later in the dispute of that ZK proof, we're ensuring that the same data is used as input to that circuit as well for the disproof. And with garbled circuits, it does give a little bit more. So with the original BitVM2 designs, we were already sort of pushing the limits with the amount of data you had to commit to for a regular, Groth 16 proof and minimal statement. And you already had the CRS and the binary relation baked into the circuit ahead of time, so it wasn't changeable. With garbled circuits, there is the potential to, and I haven't done a deep dive on this, but I do think that you could theoretically implement a post-quantum signature algorithm in the garbled circuit, because with garbled circuits, you're moving pretty much all of the computation off-chain to be very informal about it. And so you can have much larger circuits that actually perform the ZK proof verification. And then that gives you additional headroom for attesting to more data. And the actual way that you attest to, or commit to data rather, in a BitVM style approach is with Lamport signatures or Winternet signatures, which are hash based, and those themselves are quantum resistant. So theoretically, you could have the verification for ZK proofs in a BitVM3 style garbled circuit based construction use a post-quantum ZK proving system. And again, it depends on how optimized we can get the proof sizes for post-quantum ZK proofs. And, it's still a very wavy, we'll see where that lands. But even with that, you still have the issue of covenant emulation with BitVM. So even if you're able to do a post-quantum ZK verification or ZK proof algorithm that's verified as part of the BitVM style circuit that you're committing to and optimistically computing in the case of a fault dispute, the covenant emulation side would still be vulnerable to quantum computing attacks, because with BitVM you have the one of n security, one of n trust model of the construction of the Bitcoin transaction graph that enforces the BitVM style spend conditions. And to construct that and keep it secure, you have a giant multi-sig group or a threshold signature group who is signing all of these different transactions. And so that part of the protocol, you would still have a public key somewhere exposed that is for the covenant emulation committee. So even with BitVM and implementing post-quantum in the ZK verification, you still have that issue with covenant emulation. And there may be a way theoretically you could get around that using some sort of smart MPC design. Maybe there's something with, certainly if you had witness encryption, you could create a system where you can only decrypt transactions. So a combination of witness encryption and MPC could be used to create the Bitcoin transaction graph in a way that the actual transactions can only be decrypted if you had a ZK proof that you're the right participant in the protocol to decrypt that part of the Bitcoin transaction graph. But witness encryption is not far enough along that that's a practical reality. And you'd also need this to be post-quantum witness encryption, not just regular witness encryption. So even with BitVM style stuff, as far as things look right now for practicality, the Bitcoin side Bitcoin would still need to adopt post-quantum in order for any sort of construct, even with BitVM and post-quantum ZK verification in the BitVM circuit. So That's an open problem. Bitcoin could do a small change that let people start using Lamport signatures for their actual raw Bitcoin transactions, which would be very interesting. The problem is right now you can verify a post-quantum Lamport signature in Bitcoin script. That's, like I said, that's what BitVM is already doing, not for post-quantum reasons, just for it's a efficient one-time use signature algorithm that we can enforce in Bitcoin script. But the problem is Bitcoin transactions, or the execution of Bitcoin scripts, doesn't have access to the data of the transaction it's signing. So you could have a Bitcoin transaction that has to validate a Lamport signature, but you couldn't have the script verify that the Lamport signature is signing the data of the Bitcoin transaction you're sending. And so one sort of, not saying this is the right solution, but one easy thing, if the Bitcoin community can't decide on the actual post-quantum algorithm they want to use, they could update Bitcoin script just to allow you to push the TXID or some parts of the transaction onto the stack, and then you could implement theoretically post-quantum crypto for securing Bitcoin transactions using that as a stopgap. But again, everything with Bitcoin moves slow, like JCB pointed out, and we'll see where that lands. But again, not an imminent threat. The other thing with post-quantum is the current signature algorithms we're using have been in use for a long time. They're very secure. They're very well understood. And a lot of the post-quantum cryptography, obviously there's been tons of research, tons of time and resources devoted to finalizing post-quantum algorithms, signature algorithms, ZK proof algorithms, encryption algorithms. But fundamentally, these are newer bleeding edge tech. And so there's also a balance between the threat, the practical threat of a quantum computer attacking the very well-established cryptography we have today, like ECDSA signatures, versus, okay, this thing, we believe it to be post-quantum, we believe it to be quantum secure rather, but it's also less studied. There may be a classical attack against it that we're not aware of yet. And we've actually seen that with, it's been a while since I looked into this, so I can't name names, but as part of the NIST finalization for some of the post-quantum signatures, there were classical attacks found against some of them that reduce them to even less than current signature algorithm security. And so there's always that trade-off. You can mitigate that by having, needing both an ECDSA signature and a post-quantum signature. And then if either one of them is broken, either ECDSA by a quantum computer or post-quantum algorithm by some sort of classical attack, then you still fall back to the security of the other. And so I don't know if this is part of Ethereum's approach, but one of the things for eventually when Hemi does adopt post-quantum cryptography would be trying to do it in a way that we're not trading out one problem for another. So it's sort of in a similar vein as proof diversity for ZK proving systems, right? There might be an exploit in one proving system, but if you use 3 and need 2 out of the 3, then you're secure against pretty much anything that could go wrong unless they're relying on the same, underlying mathematical assumptions, and something about that's fundamentally wrong, which is a lot less likely.
One thing that, Max, you just said that I really, really want to drive home, because you said it quickly, but it is super important. Cryptography, there are, if you have some sort of cryptographic, signature scheme or something, all it needs is one attack against it for it to be a problem. That's why why a lot of cryptography tends to be old. Bleeding edge and security for cryptography really don't ever go together. Lamport signatures, for example, those are older than me, and at this point I'm pretty damn old. You need if someone comes up with something quickly, it's very literally not any good until it's been peer reviewed, until it's been out there in the wild and attacked for an extended period of time. So there's a reason why we have a lot of old cryptography. It's because cryptography takes time to actually mature to the point that you can trust it.
Yeah, for sure. And it's also, there's 2 parts to that. And again, I know we're already spending a lot of time on this, but I think it's fascinating, and a lot of people are, not looking at post-quantum or quantum-resistant cryptography realistically, and you have the actual math underpinning, you have the mathematical assumptions underpinning the design of the cryptography itself, and then you also have the implementation of the cryptography. And so there's been a lot of issues where the underlying cryptographic algorithm is secure, but there was something about the implementation that made it insecure. So as a really dumb example, like ECDSA, every time you sign a message with ECDSA, you need to create a random nonce that is not predictable. It's not related to any of the other nonces that you've used for signing, and nobody gets access to it. And if the implementation doesn't enforce that correctly, and we've seen this, I believe, in some Bitcoin transactions that used some sort of predictable nonce generation pattern, then it doesn't matter how secure ECDSA is, the implementation didn't adhere to something correctly, and there's an issue. There's a similar thing with the threshold signature implementation for ECDSA. It was used by a lot of the major like MPC wallet providers, and Fireblocks found it. And there was basically one constraint that wasn't enforced correctly, and it could be used by anyone who's in the MPC setup to maliciously craft shares of data that they're sending to other signers as part of the signing process and get them to leak information mathematically about their key shards, and that can be used to compromise. Again, it's not an issue with ECDSA; it's an implementation issue with how the algorithm for MPC computation of the ECDSA signatures was implemented. And so there's a lot of nuance, and so you don't just have to wait for the cryptography to be peer reviewed and everyone to go, okay, yeah, nobody's been able to find an issue with this for 5 or 10 years. But also we have implementations that have been used widely out in the wild with a clear bounty for compromising them, and nobody's found an issue with it, and it's gone through audit. So it's a lot more nuanced than just, hey, there's post-quantum cryptography. The other thing with quantum-resistant cryptography is right now we know that ECDSA and RSA and the similar family of signature algorithms can be broken by Shor's algorithm. But that's because somebody sat around and thought about it and came up with an algorithm for it. And all of the new quantum resistant cryptography is based on different underlying mathematical assumptions of hardness. So we are also assuming that, with say lattice-based cryptography, and there's a couple of assumptions, it depends on the lattice-based crypto you're using, but a lot of the lattice-based crypto relies on the fact that the learning with errors problem over large dimensional lattices can't be broken by quantum computers. There's no mathematical proof that that's the case, and I don't think there ever will be. It's just nobody's figured out a quantum algorithm for breaking the learning with errors assumption yet. And so we say, okay, no one's broken it with, no one's come up with a quantum algorithm for this, so we're going to use it as the computational hardness assumption that underpins a new family of cryptography. And again, learning with errors over lattices has not been around nearly as long as prime number factorization, and so there hasn't been as much thought put into being able to potentially break that with a quantum computer. So maybe it is fully quantum resistant, and that's the current working assumption, but the post-quantum or quantum resistant cryptography, there's not a mathematical proof that it is quantum resistant. It's that we haven't figured out a good quantum algorithm to break its fundamental underlying mathematical assumptions yet, and that may not be the case forever.
Yep. So I would actually phrase that as when we all of us say quantum resistant, what we really mean is resistant to any of the currently known quantum algorithms.
Yeah, if Shor hadn't invented Shor's algorithm and nobody else bothered to do it, we would think ECDSA was quantum secure. So anyway, with that, I will, sorry for the ramble, I will turn it back to Rick.
All right. So for the question, will quantum computing destroy Bitcoin ETH in the future? Maybe. Maybe. That's what I pulled from that, guys. I'm sorry. That was very in-depth and awesome.
I think that's a good summary. Basically, yes, there's ways to upgrade it, but those ways aren't quite as rock solid as some people may think, and they need more time to mature.
All right. And there is our soundbite. For other sound bites, check out the Hemi community. No, I'm just kidding. I was going to plug the store again, but there wasn't a natural tie there. All right, we got a couple more, and then we can wrap things up for the week. When will the Bitcoin tunnel and the sequencer be decentralized?
So it's a gradual process over, probably Q1, Q2 of next year. So we are going to be introducing a Bitcoin tunnel upgrade that'll have a hybrid model where people can run their own over collateralized vaults, and also we'll have an institutional custodianship component to it. So we'll announce more details on that probably in the coming, 3 to 4 weeks. And then that eventually gets us to hbitVM, which is the fully decentralized ideal version of the Bitcoin tunnel, which will again have that one event security guarantee with a large N and that anyone can be a part of. So for anyone who participates in all the covenant emulation committees, hbitVM, I don't want to call it Bitcoin custodianship because at that point it's not really custodianship, it's protecting Bitcoin mathematically with a certain honesty assumption that's extremely robust. But for anyone who wants to participate in all the covenant emulation committees, for you it'd be entirely trustless because you just have to trust yourself. So that's the timeline there. And then for the sequencer, again, probably the sequencer, it'll be post hbitVM. So, for now, hopefully sometime in Q2. And that'll be, again, as we've talked about probably ad nauseum in previous Midweek Maxes, but the decentralization of both of those, both hbitVM from the covenant emulation and operator side, and also the sequencer decentralization side, is all going to be based around VE hemi staking. So people who have a sufficient amount of hemi staked into a VE hemi position, or more correctly, an appropriate amount of VE hemi stake weight in their position, will be able to opt into those protocols and participate either as covenant emulators for people with large amounts of Bitcoin liquidity that they want to use in the system, as well as hbitVM vault operators, and as sequencers producing blocks and attesting the blocks on the network.
Right. And we have just two more quick ones. Well, I'm not going to say they're quick ones because I really don't know the context. Have you heard of Polkadot, the technology, not the token? And if so, what are your thoughts about it?
It's been quite a while since I did a deep dive on Polkadot, so I'm not sure what they're up to nowadays. As of a couple of years ago, I mean, they were doing some interesting stuff with the way that they were structuring consensus. I still prefer Ethereum style. And again, I'm working with, fairly old data here, so they may be doing some more innovative stuff recently that I'm not read up on, but it's a interesting technology. But for everything related to Hemi and what we're doing from a consensus perspective and from a cross-chain interoperability perspective, I think there's not a lot of overlap or ideas or concepts in the Polkadot ecosystem that we adopt in the Hemi ecosystem directly. I don't know if anyone else on the team is more read up on recent Polkadot developments. I will take that as a no.
I too will take that as a no. I think JCV is still thinking about quantum computing.
I think we all are.
I think we all are.
I
All
will
right.
say Polkadot's like whole build, that V2 build out, with they're building like a supercomputer, which is pretty cool. It actually goes hand in hand because they're doing a bunch of like quantum resistant stuff. So you know, that's like a pretty cool angle right now. I haven't watched as much with them because they kind of, I feel like all the substrate stuff fell off, or at least isn't as optically viable as it was a couple of years ago. Used to be big into like Polkadot, KSM, and all the substrate stuff, but really kind of interesting. I did actually check in on this a couple weeks ago on their whole like supercomputer narrative built on the blockchain, and it is enticing to read up on, but I think that they will definitely. It's a long build out. It's going to be a long time before we see what they're trying to build. So that's all I know. So
Oh, cool. Yeah, I'll have to check on them and see what they're up to these days.
Sounds a little like Skynet. And every time I hear supercomputer, I think Skynet, and then eventually Terminators. Maybe
Well,
that's just me.
nowadays every supercomputer is an AI supercomputer, right? So
I was just watching Mission Impossible 7 last night, and yeah, that definitely resonates. But one thing I will say, like Polkadot's like 2.0 narrative, they have two things that are kind of cool. The like social recovery has been really big with them since early days. Actually, I did like a beta test or an alpha test where they had like a social recovery dynamic, and like that's being like fully implemented across the chain. And then like they have something called Jam. I think it's like joint accumulate machine or jam accumulate machine or something like that. And it's instead of using like relay chains, it's a fully decentralized supercomputer. So they say that their governance it's supposed to end like the build out's supposed to be done by the end of 2026. I think it'll be like a 2030 minimum narrative on that, just based on what the build out looks like. But they're looking at also building on parachain. So we have like nothing in common with them really, but it is cool to see that tech that I think is pretty isolated from the rest of the like EVM and chain space is doing things that could very well take some narratives and some learning from it, like the social recovery, as well as like the JAM model. So I will now shut up about Polkadot.
I do like that you brought up social recovery, unrelated to Polkadot, but I think one of the crypto has always struggled with adoption and usability, and as good as it is to tell somebody go buy a couple of Trezors and set up a sharded private key with Shamir secret sharing and blah blah blah. The reality is onboarding the entire world onto crypto, you're not going to do it that way, and so having right now people's options are essentially, do I trust somebody else with my crypto or do I trust myself with my crypto? And I think the social recovery side, especially now with some stuff we can do with account abstraction, making that more accessible to users is a huge win for sort of that midpoint where it's, hey, I don't mind managing a key, but I want to be able to bake in certain provisions where I can, with a group of trusted friends, I can recover my key, but they can't collude and steal my funds. And having more dynamic configurable setups around how you can have sort of a partial trust model where it's not as secure as holding your own key with really good backups and redundancy, but it sort of serves that midpoint between the users who just want to register with an email address and the users who want to go balls to the wall and have a fireproof safe with their private key carved in the metal. So I do think there's a lot of over the next year, I think we'll see a lot of interesting stuff in the social recovery scene, or technology stack that makes crypto adoption a lot easier and again sort of serves that middle use case for a lot of people. So looking forward to seeing more of that develop.
Yeah, something that I've seen like brought up a lot in like the demo style circle is a combination of like social recovery and like biometric or enhanced social recovery, so that there's like instead of requiring maybe four other signers in order to recover, I can do like 2 plus biometrics. And there's like different versions of that like make it more viable. Because I think one of the things with social recovery that I always see is it's like crazy numbers that to make it like really, really secure. So on the high end, like on the institutional end, Binance, for example, or some large entity, to do social recovery, which I mean, it's not really feasible. It doesn't make sense in the first place. But on the far spectrum, the numbers, I think it's like 16. Like other signers is like one of the numbers that I hear a lot, and it's just like not feasible. So it's like, okay, if you were to add in additional like biometrics or other on-chain, off-chain data that can be verified, to make sure that it's the actual person controlling it, they're not under duress, stuff like that. That's kind of cool. So I think we'll see like a molding and a fusion. I know we actually had a team call that got brought up yesterday, but I think we're going to see a fusion of like some of these like identity paradigms alongside like social narratives for recovery and for other types of operations.
And definitely a lot of interesting stuff there. And I remember there was a team we met, I I think it was at the Dubai conference, but and I didn't do a deep dive on the tech behind it, but they're very knowledgeable, real cryptographers, and they know what they're doing. It's not a some sort of BS setup. They had a private ZK proof of biometrics. So previously, I had a very low opinion on ZK proving biometric stuff because there's always, again, a source of truth that you're validating against. But they did some interesting things for being able to create, in massive air quotes, a cryptographic hash of your face. And they also had some other cool stuff with being able to associate that with some sort of secret that only you'd know, like, almost like a Harry Potter Horcrux or something, I think is how they described it. Or it could be, it's your face and then you're holding up a certain page of your favorite book or whatever. And being able to ZK prove that privately and prove it against the publicly known, cryptographic garbled version, not garbled, officially in the cryptography term, but this garbled version of your identity, and then this other like private identifier, so somebody couldn't just snap a picture of your face and recover your stuff. They'd have to know that your favorite book is Twilight or whatever, and your favorite page is 132. So there's interesting stuff around that as well that I think probably won't see stuff like that hitting mainstream this year, but there's some interesting, more private, more trustful, theoretically ways to do some sort of biometrics. But there's still issues potentially with that approach. But it is interesting to see that space developing too.
Two comments quickly. I don't, was I there for this? Because I feel like I remember the Horcrux that mentioned specifically. So
I think you know the guys for sure. I'm not sure if you were at our conversation about it, but you definitely know the guys. I'm trying to remember the name of their group, but
I gotcha, because that exact like that wording is something that I've heard used. And then also one last thing on Polkadot I thought was interesting, that actually I remember how they came up on the map a couple months ago. Like a good amount of their community like kind of flamed out and was like, okay, we like this narrative, but it's going to take a long time, so we don't want to wait this time. Instead, let's convert all the dot to Bitcoin. And that was like a big thing. So they wanted to do like a full conversion from dot to Bitcoin, and build like a, I don't know, Bitcoin based chains on Substrate. So just remember that, kind of an interesting thing. I think it's like one of the only times that a community is, it's not like a fork or anything. It's a literal turnover of assets. So I thought that was kind of cool.
All right. Just going off a comment I saw in chat. Max, who is your favorite character from Twilight?
I have not read the books or seen the movies, so
Okay, perfect answer. All right. Our final question of the day. Oh, it's one of those things that I have no idea how to say. Max, can you Eli 5? ELI 5?
explain like I'm five.
Sorry, say again?
Eli, explain like I'm five.
Okay. Oh, Jesus Christ. Okay. I'm
Not just a
sorry.
guy.
I thought it was like a term, like, that I had no idea what the hell it was. Okay. Can you please explain proof of proof like I'm 5 years old? And if you can't do that, we can do it in the next episode of our educational series that is still in development and ready to launch.
We will definitely do a much more well thought through and scripted version of it for the educational content. I'll try to make this simpler than the last time I ELI5 this. So proof of proof, basically, normally with a proof of stake network, there's something called weak subjectivity, which basically just means that somebody who controls a bunch of consensus power, or the ability to make and sign and attest to blocks at any point in the past, can create an alternate chain essentially for free, using your laptop and 5 minutes of compute, can create an alternate, completely valid looking chain that for nodes on the network, they can't distinguish the current canonical chain versus that alternate attacking chain that was made with a bunch of old staking keys. And so with that is an issue with Ethereum today. They've for the most part, solve that by essentially adding in rules that say, an Ethereum node that's in sync is not going to accept a long reorg, right? And the way they do that is with the finalized epoch that all the nodes saw attestations to, they agreed to. There is still a vulnerability in there with chain splitting. So whenever you have rules like nodes never accept a fork if they're at, beyond this height, or if they consider this block finalized, because information doesn't transmit over the internet instantly. There is a delay, and some nodes hear about some data before other nodes hear about that same data. There's always fragmenting vulnerabilities, but to execute that on Ethereum today, you would need to have a large part, a super majority, more than 66.6% of the current active staking power, which we basically assume is impractical for most use cases. Ethereum also disincentivizes this with slashing. So if you sign two conflicting attestations that say, I want to finalize this block and this conflicting block, or more formally, this epoch and this conflicting epoch, then somebody can bring a cryptographic proof that you lied about that on chain, and then the protocol can validate, yep, you did sign two conflicting pieces of data, therefore we're going to slash you. But fundamentally with proof of stake, there's no way around some version of the nothing at stake problem still existing. And as a side note, that's one of the things that we're improving with hbitVM. And this comes back to POP. I'm not going on a consensus rant. But so with Ethereum, with proof of stake, no matter how it's implemented, whether it's Ethereum style proof of stake, whether it's, Tendermint style, now they changed the name, it always slips my mind. But any of those proof of stake systems either have they always have weak subjectivity, and they have different design trade-offs in how they address that. And so with a network that's based on Ethereum proof of stake, and eventually we're adopting our own native proof of stake for decentralizing our sequencer, there's no way to fully protect against that nothing at stake attack vulnerability class. And so Bitcoin using proof of work is what's referred to as objective. So it's, instead of being subjective, it's objective consensus, meaning that given all the information, all nodes will agree on what Bitcoin should look like. So assuming you're not able to censor traffic completely on the peer-to-peer network to a certain set of nodes, all nodes on the network will eventually hear about all information and eventually agree on the tip, which is not the case in Ethereum, again, because depending on when a node heard about one chain versus another, they could finalize different views of Ethereum and refuse to agree to that. And when any decentralizes consensus, you would have a similar problem if you just use proof of stake directly. So proof of proof solves this by basically inheriting Bitcoin's objectivity from Bitcoin's proof of work, and then using that to determine what the canonical chain is. So no matter what happens under the hood of proof of stake, there's always a objective, referenceable, correct state that can be determined from publications of a chain, in our case, Hemi, to Bitcoin. And then one of the things we're doing with hbitVM is we're expanding proof of proof to provide this protection to Ethereum. And so not only will it be the Hemi chain is published to, or a summary, in air quotes, a cryptographic summary, basically headers of the Hemi chain are published to Bitcoin, and you can always look at the objective truth of Bitcoin and then say, from that objective truth of Bitcoin, what is the objective truth of the current state of the Hemi chain? But with this update to POP for hbitVM, we're also going to be publishing data from Ethereum to Bitcoin, so that for use cases of Ethereum, specifically in a zero knowledge context, there is always an objective truth version of Ethereum that you can always point to, even in a ZK context, which is a harder problem to solve because by definition, a zero knowledge proof reveals zero knowledge about what you're proving. And so even in the classical Ethereum attack case, if you were to produce a valid alternate Ethereum chain from old staking keys in a zero knowledge context, you could prove that that alternate chain you created is perfectly valid, and you could confuse a ZK verifier. So even if you couldn't confuse the actual Ethereum network, you could confuse a ZK verifier that's, say, for our cases, in a hbitVM vault. And so by publishing Hemi and then in the future Ethereum some data about their respective consensus to Bitcoin, you can use Bitcoin as this objective truth layer that everyone knows what Bitcoin looks like. Everyone agrees on the current state of Bitcoin. And from that, regardless of what's happening with proof of stake, under the hood, you can always point to a version of both of those chains that is deemed canonical based on this objective source of truth of data published to Bitcoin. So that's the fairly high level. The summary is basically proof of stake has a lot of benefits, but it has some issues and problems with being able to always establish objective truth. That's what Bitcoin's best at. And so we can use Bitcoin and publish data from these chains that natively would be subject to subjectivity. We can publish data about them to Bitcoin, and then that can make those consensus protocols objective. And then proof of proof, since we're just publishing public data to Bitcoin, it's natively decentralized because anyone can get access to the data they need to publish. Anyone can construct a Bitcoin transaction that publishes that data to Bitcoin, and then the protocol sees those publications and then pays out a reward to those people who perform the publications needed to provide that objective view of Hemi and in the future Ethereum based on publications of their respective consensus data to Bitcoin.
All right. Thank you for that. I think the challenge for that episode, Max and JCV, is not to explain it to me as a 5-year-old, but make it so I can explain it to people as a 5-year-old. Because, as Josh pointed out, not many people have full understandings of Ethereum and consensus protocols.
So wait, Rick, in that scenario, are you explaining it to a 5-year-old, or are you explaining it to someone as if you were a 5-year-old?
Yes. Both.
Okay.
We've got
We
our
have to
work cut
cover
out for
both.
us.
We have to cover both. All right. What is this? What is the equivalent of a DEX but centralized? You son of a bitch. It's a centralized exchange, Alex, is what it is. That's what it is. Nice try though. Circle gets the square. All right. Oh good God. Okay, we have one more question and then we can wrap it up. Is POP patented?
Short answer, yes. Actually, this is something we were just discussing internally. So POP, particularly fork resolution, is patented. We are going to be, not sure the exact timeline, but we are going to be putting out some sort of a license for it to people who adapt the POP miner for use in the Hemi ecosystem. So short answer, if you don't worry about anything related to the patent at a high level, if you want to, make changes to the POP miner or have a fork of the POP miner that you maintain, as long as the use of it is on the Hemi network, we're going to have some more formal legal wording that basically guarantees your ability to do that. And then obviously with chain builder, the definition of that's going to get expanded to chains in the Hemi ecosystem or that use Hemi as a POP aggregation layer or something of that sort. So short answer, yes. But if you're doing anything that relates to POP in any way that is within the Hemi ecosystem, that's perfectly fine and encouraged, and we will have more formal legal wording that basically ensures that protection in the near future.
All right. Thank you for that. A couple quick things at the end. There is a how is this phrased? There is a reveal for Sacred Waste, who was on our show a couple weeks ago. That's happening tonight for those who participated. I propose that we make an intern NFT so people can sacrifice it to the good folks at Sacred Waste, and I can live vicariously through them. I think that would be fun. And beyond that, there is a rumble happening on the Hair server immediately following Midweek with Max. But with that said, we had a lot of ground that we covered today, and I want to thank all the amigos for showing up. I want to thank our moderation team for continuing to do amazing work. And yeah, the holiday season is approaching, so you know, there's a lot of stresses and a lot of gift giving. And what better place to look than the Hemi Community Store? Available on the Hemi Merch Store. Look up the community collection. Magnets, shirts, stickers, mugs. That's the last shill I do, I promise. But I just had to. There was a natural influx there. So, with that, I'm going to turn it over to Max and team, and I'm going to get the hell out of here because we got a mod meeting. And Oh, wait, sorry. Oh, good God. I'm so sorry. We have one more thing. Oh, good God. Okay, sorry. There was one more question. When free merch giveaway during Midweek with Max? The answer is now, as Joshua reminded me. Josh, did you do the random roll? Hold on, I'm waiting for it. Okay. Congratulations to Citizen Nath on winning a Midweek with Max t-shirt. We will be doing these what the hell? We'll do them weekly. So, show up to Midweek with Max and you could win some merch. Okay, now with that said, Josh will be getting with you soon, Citizen Nath. We just need some info from you, and we'll get you a Midweek with Max shirt. Okay, but now I'm really, really rambling, and I apologize, folks. Turning it over to Max and team. Thank you to everyone. If you celebrate Thanksgiving, have a great holiday to those who celebrate. And I will shut up now. I apologize.
All right, awesome. Thanks everyone for coming to a 30-minute longer than expected because we rambled about post-quantum cryptography. But thanks everyone for coming to another Midweek with Max. Lots of exciting stuff. So stay tuned for the announcement around and launch of staked hemiBTC. Stay tuned for the HBitVM white paper and scheduling probably next week a breakout additional AMA to answer anyone's tech questions about that protocol. And with that, we will see you next week. And for those of you who celebrate, echoing Rick, have a great Thanksgiving.
Yep. Thanks,
Take
everyone.
care, amigos. Sorry, JCV.
Nope. I was just saying thanks, everyone, and bye-bye.
Hey, thanks, guys.
All right. Take care, all. Hemi strong.